Welcome to Laser Safety Training, Class 3B and 4 Laser Controlled Areas. This training module provides basic awareness of laser safety. The video will introduce you to a typical laser controlled area. Here we will identify what you are likely to see, the potential hazards, and the control measures used to protect yourself and others. Before entering any laboratory, it is important to know the type of environment that lies ahead. The best way to do this is to pay attention to the signs and notices at the entrance. These will tell you what type of lasers are inside and tell you whether or not the lasers are active and tell you what procedures are in place to ensure your safety whilst in the lab. This notice warns us that we are entering a laser controlled area or an LCA. When a laser is active, the sign lights up. The laser controlled area may contain lasers with different wavelengths. This may be displayed on a wavelength indicator box. The relevant indicator lights up to let you know which laser is currently active. Another important sign to notice is the oxygen depletion monitor. There are two of these, one on the inside wall and one on the outside wall of the lab. These indicate the oxygen level inside the room. Various types are in use. For this installation, a red light signifies a potentially unsafe level of oxygen, and a safe level of oxygen is indicated by a green light. Here on the door, there are signs and documents that tell us more details about the lasers inside. The document folder usually contains risk assessments, work instructions or local laboratory rules, and control of substances hazardous to health assessments, and other relevant safety information. Prior to undertaking any work in the lab, users are required to read and understand these documents. This laser control notice provides details of the following: General Area Information and Supervisory Officer, the lasers inside the laboratory and hazard information, interlock test requirements, personal protective equipment requirements and specifications. There may also be more detailed information about the lasers inside provided on the door. Before entering the lab, it is important to know if there are any users already inside. The warning signs will only tell you if a laser is active, so you should check to see if anyone is inside every time. If the lab is currently in use, you should always alert whoever is inside that you are about to come in. You may be able to use an intercom to speak to them. If there is no intercom, simply knock on the door and wait for a response before entering. Entry is always restricted for areas containing hazardous lasers, and you will usually need a swipe card or a secure numerical passcode to enter. Some areas may require the use of a personal access key. Access should only be made available to authorized personnel. All other persons must be accompanied by an authorized member of staff, whatever their reason for entering the lab. The lab door is monitored by an interlock control box, which is also connected to the laser systems inside. When an access code is entered or an entry card is swiped, the door lock releases and the interlock is overridden. Immediately on entering the lab, you will often see a wall partition or screen between the door and the laser itself. This is in place to protect you from any direct exposure to possible stray beams from the laser as you enter. You can usually find the interlock control box near the entrance. From here, the entire remote interlock system can be activated, deactivated, and monitored. You will also find a storage box containing personal protective equipment, or PPE. In almost all situations, this box will contain at least one pair of protective goggles. Some areas may require that you have your own set of goggles. With very powerful lasers, you may also have additional protective clothing. For example, gloves, aprons, face masks, visors, or protective footwear. Laser goggles can provide protection from single or multiple laser sources, but generally, the more laser wavelengths that the goggles protect against, the less usable they are. This is because less light is transmitted through the filter and certain colors are obscured, making it difficult to see clearly. With this in mind, there may be a tendency to want to remove the goggles to see more clearly. It is important to remember that the correct goggles specified for the laser in use must be worn to prevent eye injury when lasers are operating. You should also remember to remove all reflective clothing, jewellery and objects that may be on your person before entering the main lab area. Moving further in, you will notice that the general environment is designed with user safety in mind. The room is well lit by artificial light, and there are no windows that could allow stray beams to escape. The walls also have a matte surface which is able to diffuse laser light and prevent reflections. This is an optical table. These are usually enclosed to help avoid stray beams. For the purpose of this training, we will show the table with its enclosure removed. There are many components that can be found on an optical table, including the laser itself, beam shutters, periscopes, beam splitters, fiber launchers, fiber patch cords, mirrors, and diagnostic equipment. Some equipment may be connected to a computer that is able to control the experiment and measurement data. The laser itself is activated by a key-controlled power supply box, which may also be connected to the central interlocking system. The control box near the door entrance powers remote interlock switches located around the lab. These control separate beam shutters and make-break relay sockets, of which any laser of class 3B or 4 must have according to laser safety standards. If we were to follow the cabling path around the room, we would see how the remote interlock plugs connect up through the gantry, along the ceilings and walls, to the interlock control box. There are many types of lasers which span the visible spectrum and go beyond into the ultraviolet and infrared. The hazard changes as the power or energy increases, and also if the output is pulsed or continuous. In this case, we are demonstrating a water-cooled, green, high-power laser. The output from the laser beam is passed through a safety shutter, which is connected to the main interlock system. Here, the beam is initially delivered through free space. It then passes through a periscope to change its height and is split by a cube beam splitter before being launched into fibre. The fibre relaunches a highly divergent beam into free space, which is then reflected onto the measurement instrument using a mirror. Safety engineering controls for the beam delivery might include beam tubes, beam stops for periscopes, beam dumps for stray reflections from cube splitters, and protection for fibre launch optics. The launch of the beam into free space reduces the hazard of the beam as soon as it has diverged sufficiently. Now let's look at the hazards associated with the process. As mentioned earlier, if protective goggles are removed, the risk of eye injury increases dramatically. A laser eye injury can cause serious permanent damage to your vision. This is an example of an eye injury caused by a visible laser beam. It shows the initial effect of a retinal burn to the central portion of vision. In the event of such an injury, please follow the emergency procedure outlined in your laboratory safety documents. Note that lasers can also cause damage to the skin. Be aware of other potential hazards associated with an active laser. Fire. Using burn paper to enable an infrared beam to be seen can also be dangerous, creating a fire hazard. High voltage. Some lasers have high voltage power supplies associated with them. This, combined with possible leaks from the laser water cooling system, can expose a user to an electrocution hazard. Stored energy. Pulsed lasers often use capacitor banks to provide the energy, which produce pulses of light to pump the laser. These stored energy devices can be a significant hazard, even when disconnected from the electricity supply. Noise. Powerful lasers also pose a noise hazard that could potentially impair a user's hearing. Noise often causes difficulty with communication in the lab. X-rays. Some high-powered lasers can generate X-rays when directed at certain materials. Shielding is often used to reduce radiation exposure. Please ensure that you are familiar with your risk assessments, which will highlight the hazards within the lab and the control measures. Upon leaving the lab, It is good practice to always ensure that the lasers are switched off and all instruments and apparatus are returned to their original positions ready for the next user. If lasers are to be left on, an override button can be found by the door, which defeats the interlock system and allows you to exit. This module has provided you with basic measures of laser safety. We have identified what you are likely to see in a typical laser-controlled area, the potential hazards, and the control measures used to protect yourselves and others. The hierarchy of controls in this area are engineering controls, including interlocks, beam tubes, enclosures, shutters, and partitions. Administrative controls, for example signage, documentation and training. Personal protective equipment, which can include laser goggles and other protective measures. This concludes this module. For more information and questions about basic laser safety, please consult your laser safety officer.